Hello dear students, welcome to mathematics class. In this class let us discuss remaining examples on the third case of particular integral. So this is the first example of today's class. Solve the differential equation d square minus 4d plus 4 into y is equal to e power x plus x square plus cos 2x. So here we have three functions on the right hand side of the given differential equation. So one is e power x, that is the first case of particular integral, then cos 2x, that is the second case, and x square, now that is the present case of finding the particular integral. So here the complementary function of this one is c1 plus c2x into e power 2x, means the roots of this equation are 2 and 2, means the 2 is repeated twice. So therefore the complementary function becomes c1 plus c2x e power 2x, and the particular integral is 1 divided by f of d. So f of d is d square minus 4d plus 4 into e power x plus x square plus cos 2x, and the next step is to write the function in the denominator for each and every function present on RHS. So therefore here we have three functions, then write the denominator separately for all the three functions. Now the first function is e power x, x square and cos 2x. So in these three functions I am solving the particular integral only for the second one, that is 1 divided by d square minus 4d plus 4 x square, and remaining these two are those two can be solved by u. So therefore here it is equal to, so therefore this is equal to, I am considering only x square, so 1 divided by d square minus 4d plus 4 into x square plus this one and plus the next cos 2x. So you have to solve these two, and here the first step of finding the particular integral is we need to take out the lowest degree term outside. So here the lowest degree term is 4, so therefore that becomes 1 by 4 into d square by 4 minus d plus 1 x square, because that 4d becomes d because that 4 we have taken outside, and here there is no 4 means in denominator that will be 4. So is equal to 1 by 4 into, let us write this in the systematic manner, that is 1 plus d square by 4 minus d x square, then it is equal to 1 by 4. And now let us take this to the numerator, that becomes 1 plus d square by 4 minus d whole power minus 1 into x square. So here power of x is 2, then we can consider d and d square, because d is the first order derivative and d square is the second order derivative. So therefore we can consider d and d square, and we can eliminate all the higher order derivatives like d cube, d power 4, d power 5 and so on. Now it is 1 divided by 4, so it is of the form 1 plus x whole power minus 1. So expansion of that one is 1 minus x plus x square minus x cube and so on. So therefore 1 minus x is d square by 4 minus d plus x square. So here we need to consider x square, because so here d square by 4 minus d whole square. So after expansion of this one we can take d square, because there will be one d square term. So therefore we have to consider this one, and the next term will be x cube. So if you consider x cube, there we cannot get any d square or d, so therefore we are not considering the remaining terms into x square. Then it is 1 by 4, here 1 minus multiplying by this negative sign, that becomes minus d square by 4 plus d plus so here it is of the form a minus b whole square. So expansion of this, that one is a square plus b square minus 2ab. So if you consider a square, that becomes d power 4 by 16, which is greater than 2, so cannot consider, and b square. So b square is what? D square, we can consider, and 2ab term will be d cube, because here it is d square and d, we need to multiply these two, that becomes d cube. So therefore that is the higher order derivative, so need not be considered. Then it is 1 by 4, here 1 plus d, here minus d square by 4 and plus d square, that becomes plus 3 by 4 d square of x square, because 1 minus 1 by 4, that becomes 3 by 4. Then here it is equal to 1 by 4, then multiplying by x square, that becomes x square plus d of x square plus 3 by 4 d square of x square, then it is equal to 1 by 4 x square as it is, d of x square means differential of x square, that is 2x plus 3 by 4 d square of x square means differential of 2x, that is 2, then it is equal to 1 by 4 x square plus 2x plus 3 by 2. So here this is the particular integral only for the function x square, and remaining two particular integrals are there, one is e power x and one is cos 2x. So complete the particular integral and hence write the general solution or complete solution as y is equal to cf plus pi. Next example, d square minus 5d plus 4 into y equal to x square plus 7x plus 9. So here it is of the form x power m only, because here x square is the highest power of x, so we can differentiate this one and we can get the derivative equal to 0 after some differentiations. So here the power of x is, or highest power of x is 2, means we can differentiate this 2 times. So after the second derivative, all the higher order derivatives will be equal to 0, means here also we can consider d and d square, not d cube, d power 4, d power 5, means the next remaining higher order derivatives can be neglected. So now here complementary function of this one is c1 e power minus x plus c2 e power minus 4x, means minus 1 and minus 4 are the roots of this auxiliary equation, and the particular integral is 1 divided by d square minus 5d plus 4 into x square plus 7x plus 9. So here it is the sum of 3 functions, but here we cannot or need not be separate the denominator, because all this function is of the form x power m, x power m, x power m only, because here it is x square, x power 1, x power 0. So if you solve this by separately, then also you will get the same answer, but unnecessary you have to waste the time, because all these together is a single function. So if you split this as the 3 functions, then each time you have to take the lowest degree term outside, then expansion, so that will be unnecessary time consuming. So therefore do not separate the function if the function on the RHS is of the same type. If is x square plus e power x plus sin x means all the three are different, then we need to separate, but here we cannot or need not be separate the denominator. Then the first step of this one is taking the lowest degree term outside, that is 4. So 4 is the lowest degree term. Then remaining d square by 4 minus 5 by 4 d plus 1 into x square plus 7x plus 9. Then 1 by 4 as it is here. Write this in the systematic way, that is 1 plus, always 1 should be. So here the first term should be is equal to 1. So therefore 1 should be written first, and remaining term next, that is d square by 4 minus 5 by 4 d into that function. Then it is 1 by 4. Now take this to the numerator, that becomes 1 plus d square by 4 minus 5d by 4 whole power minus 1 x square plus 7x plus 9. So 1 by 4. Now it is of the form 1 plus x whole power minus 1. So 1 plus x means there we will get the alternative plus sign minus signs. So therefore here it is 1 minus x, that x is d square by 4 minus 5d by 4 plus x square, that is d square by 4 minus 5d by 4 whole square. So here we know that the maximum power of x is 2. So then we can consider maximum power d is equal to 2. So therefore here we can stop into x square plus 7x plus 9, then it is 1 by 4. 1. Now multiply this with the negative sign, that is d square by 4 plus 5d by 4 plus. So here after expansion we can get d square here. So in the expansion we have 3 terms, but the d square will be there in only in the one term. So here this becomes d power 4, this becomes d square, and the another term will become d cube. So therefore we need to consider this b square. B square means 25 by 16 d square into x square plus 7x plus 9. Then it is equal to 1 by 4. Now 1 plus 5d by 4 plus 25 by 16 minus 1 into d square. So here this becomes 1 by 4 into x square plus 7x plus 9, means in these two terms 25 by 16 d square and minus 1 by 4 d square, we can take the d square outside, then we will get the this constant term 1 by 4. Now multiplying this with this, all these three terms, so x square plus 7x plus 9 plus 5 by 4 into that differentiation of this one, x square plus 7x plus 9 plus. So here LCM is 16. So after simplifying this one, we will get 21 by 16 d square of x square plus 7x plus 9. Then it is equal to 1 by 4 x square plus 7x plus 9 plus 5 by 4 into differentiation of this one is 2x plus 7 plus 21 by 16 into second order derivative of this one, means differentiation of the previous term, that becomes 2, which is the required particular integral. So here be careful while simplifying, because here if you did any mistake, so therefore the total answer will become wrong. So be careful while subtracting and adding the fractions, and also while differentiating the terms. So here d becomes first order derivative d square, second order d cube, third order, and so on. So therefore, be careful while simplifying the steps. Next example, solve the differential equation d cube minus d square minus 6d into y equal to 1 plus x square. So here it is the cubic equation, hence it has 3 roots. So here the roots are 3, minus 2 and 0. So therefore complementary function c1 e power 3x, c2 e power minus 2x, c3 e power 0x, and the particular integral. So 1 divided by f of d. So f of d is d cube minus d square minus 6d into the function on the RHS, that is 1 plus x square. So here the highest power of x is 2. So therefore after expansion we will get the terms of d, but here we need to consider only the terms d and d square. So except these two, if any higher order of d are there, we need to neglect them. So here the lowest degree term is minus 6d. So therefore 1 divided by minus 6d, that is outside. Then remaining is what? d cube divided by minus 6d minus d square divided by minus 6d plus 1 into 1 plus x square. Then it is minus 1 divided by 6d, that is outside. Then write the remaining term in the systematic manner. So first 1, here d cube divided by d, that becomes d square minus 6. So therefore d square by 6. Here minus into minus becomes plus, and d square by d becomes d into 1 plus x square. So now this is minus 1 divided by 6d, 1 divided by, this can be written as 1 plus d minus d square by 6, 1 plus x square. Then now this has to be written in the numerator, that is minus 1 divided by 6d into 1 plus d minus d square by 6 whole power minus 1, 1 plus x square. So therefore minus 1 by 6d. Here 1 minus x plus x square minus x cube and so on. So 1 minus d minus d square by 6 plus d minus d square by 6 whole square. So here maximum power of d will be 2. So if you consider the next term, that will be more than 2. So therefore we need to stop here. Then simplify this one. Here 1 minus d plus d square by 6 plus. So here after expansion there will be 3 terms, but in those 3 terms there is only one d square term. So that is a square plus b square plus 2ab. Here b square means d power 4 and 2ab, that will be d cube, only is d square into 1 plus x square. So minus 1 by 6d, 1 minus d plus 1 by 6 into d square, that becomes 7 by 6 d square 1 plus x square. Then it is equal to minus 1 divided by 6d, now multiplying by that 1 plus x square. So 1 plus x square minus d of 1 plus x square plus 7 by 6 into d square of 1 plus x square. So now here this is equal to minus 1 by 6d into 1 plus x square minus differentiation of 1 plus x square is 2x plus 7 by 6 into 2, because the differential of 2x is 2 and differential of 1 plus x square is 2x. Then here minus 1 by 6. So we know that in denominator we have d, so 1 by d means that is the integration. So therefore here 1 by 6 is constant as it is, and 1 by d is nothing but integration. Here 1 plus x square minus 2x plus 7 by 3, because 2 ones are 2 3s are, into dx, then it is equal to minus 1 by 6. So here integration of this function, so integration of 1 is x plus x cube by 3 minus 2x square by 2 plus 7 by 3 x, which is equal to minus 1 by 6. So x plus 7 by 3x, that becomes 10 by 3 into x plus x cube by 3 minus 2 get cancelled and remaining x square, which is the required particular integral of the given differential equation. And then write the complete solution as y is equal to CF plus PI. Next example is d square minus 2d plus 3 into y is equal to cos x plus x square. So here we have the two different functions on RHS, x square and cos x. So therefore while finding the particular integral we need to find separately for each function. So here the complementary function is e power x into c1 cos root 2x plus c2 sin root 2x. So here the root of this auxiliary equation will be 1 plus or minus I root 2, that is the complex pair. So here alpha equal to 1 and beta equal to root 2. Then particular integral is 1 divided by f of d into the given function. So here we need to separate, so 1 by d square minus 2d plus 3 cos x plus 1 by d square minus 2d plus 3 x square. So here as usual we have to solve that cos x, and I will solve x square is equal to, here you will write the solution for the first function for cos x, here d square equal to minus 1, and solve the remaining thing. And here the lowest degree term, what is the lowest degree term here? 3 is the lowest degree term, then 3 into d square by 3 minus 2d by 3 plus 1 x square is equal to, so here 1 by 3 keep as it is, then remaining term should be right in the standard form, that is 1 plus d square by 3 minus 2d by 3 x square, then it is equal to 1 by 3, here it is 1 plus d square by 3 minus 2d by 3 whole power minus 1 x square. So here the power of x is 2, then we can take only up to second order derivative, then it is 1 by 3. Now after expansion of this one, it is 1 minus x d square by 3 minus 2d by 3 plus x square. So x square means d square by 3 minus 2d by 3 whole square into x square. Since the highest power of x is 2, so therefore here we cannot consider the third order derivative, fourth, and so on. So therefore here in this third term, after expansion we will get the 3 terms. So among these 3 we can get only one d square, that is in a square we cannot get d square, and in b square we can get d square, because b square means that becomes 4 by 9 d square. So here we can get d square. Then it is 1 by 3, 1 minus d square by 3 plus 2d by 3 by multiplying negative sign, plus here b square means 4 by 9 d square of x square. Then it is equal to 1 by 3, 1 plus 2d by 3 plus, so here d square common, then 4 by 9 minus 1 by 3 d square of x square. Then it is equal to 1 by 3, now multiplying by x square, that is x square plus 2 by 3 d of x square plus, here value of this one is, so here the LCM is 9, right? Then that becomes 1 by 9 into d square of x square. Then it is equal to 1 by 3 into x square plus 2 by 3. So d of x square means that is 2x plus 1 by 9 into d square of x square is 2. So therefore here 1 by 3 x square plus 4 by 3x plus 2 by 9 is the particular integral for the second function, means x square. Still one function is pending, that is cos x. So therefore you have to solve the particular integral for cos x and then write the complete solution as y is equal to cf plus pi. And here these are the assignment questions for you on the third type of finding the particular integral. So here total 6 problems are there. So solve these 6 problems as early as possible and upload in the Google Classroom. So here examples are d cube minus 3d square minus 6d plus 8 into y is equal to x. So here highest power of x is 1, then here after expansion we can consider only d, because d square d cube all will be equal to 0. And second example, d cube minus 3d minus 2 into y is equal to x square. So highest power is 2, then you can consider d and d square. So d cube minus 13d plus 12 into y is equal to x square, here also d and d square. Then d cube minus d square minus 6d into y is equal to x square plus 2x. So here we have a function which is consisting of two terms, but both the terms are of the same type. So therefore no need to separate the denominator. So on combining we can solve. And highest power of x is 2. So here after expansion you can consider d and d square. And d square plus 4 into y is equal to e power x sin 3x x square. So in this problem we have to use all the three particular integrals, because e power ax sin ax x power m. And the next one is d cube plus d square minus d minus 1 into y is equal to sin 2x plus x square, here sin ax form and it is x power m. Only two types of particular integrals. So therefore solve all these examples and upload in the PDF form in Google Classroom.